Yeah, thank you very much, Netty, for that introduction. And I'm also happy to connect with the viewers and the listeners during this session. I'm going to briefly talk about wildlife forensics and genetics, with special emphasis on ivory and ivory sampling. I work in Kenya, and in Kenya today, I said that one of the challenges we are facing are issues to do with illegal wildlife trade. And for many years now, we've been facing these challenges. For the last 20 years, we have lost so many animals due to changes in land use and issues to do with peasant consumption. So for this reason, we have been losing so many animals to poachers. And that is why we established the Wildlife Forensics and Genetics Lab. So this lab was established in 2015. And in 2015, actually, we used to have very low penalties when it came to wildlife crimes. And when somebody committed a crime in 2014 and those years behind, somebody will get a penalty like $10 for punishment for killing a whole elephant. And even if you have so many animals you're caught with meat or things like that, you will get away with it because it was just so easy to go and kill for a lot of money, and then the punishment was so low. So in 2015, we introduced very stiff penalties that ensured that anybody who was caught trafficking, be it any form of a trophy, be it ivory, be it game meat, or all those kind of things, is prosecuted. So the punishment became so high, from very low punishments to 20 years in prison or even life, or sometimes up to $200,000 in punishment in terms of fines. So therefore, increasing those fines made the threshold of prosecution go very high. And for that reason, we needed to take scientific evidence to court to ensure that we win these cases. And that is why we were able to start the forensics lab. So in the forensic lab, we do a lot of work, that is starting from bushmeat work, which is really a big problem now. We have the elephant ivory issues that I'm going to address today. And then also we have the rhino poaching, among other CITES listed species. So in our lab, we have got functions of our lab. One of them is to just reliably identify wildlife species and other wildlife products that are arrested within our jurisdiction. Apart from that, also, we have established databases for species and for species identification. And then we also assist in certification and licensing for export products, those ones whose provenance is suspect. If somebody, for example, has got suspected leathers or things that is exporting outside the country, then they are brought to our lab for analysis, and we're able to tell whether it is wildlife or otherwise. Apart from that, we're also involved in wildlife genetic research. This includes population genetic studies to look at population stability in terms of inbreeding indexes, among other population indicators that will show that a population is growing well. So our lab is able to do all those. And then lastly, we also assist in disease diagnosis. Since we have vets around our country all over the place, so when they have got diseases that they suspect and they do not know what they are, we are able to help them in diagnosis using molecular tools. So as you all could be aware, is that issues to do with ivory, it is one of the biggest environmental crimes in the whole world. In the last many years, there's been a lot of trafficking of ivory for money and for other purposes that some of them say it's for medicine and all those kind of things they do. So we have been able to arrest so many containers from our ports of Mombasa, and we have been able to do provenance determination. When I talk about provenance determination, that is trying to show where the ivory is coming from. So my lab, together with other labs, one of the labs in the US called the the Washington State University lab. We have been working on ivory provenance for many years, and with the aim of trying to determine where the ivory is coming from. And usually the ivory come in this kind of containers. When through the scanners, they are arrested and caught, and then we are able to show that this particular container, for example, has got ivory. So what happens is that when during the sampling, we look for similarity, because sometimes this ivory, they could be even a ton or 2 tons, but it is very expensive to just do DNA profiles for each individual ivory. And for that matter, we usually try to get comparisons and make sure that we just sample as few representative samples as possible to ensure that we have the right genotypes and few samples as possible. So we look at different features. So we group them for similarity, and then select a given number that is going to be unique to us and that is going to help us do that kind of assignments. So for example, if you look at the photos I'm displaying right now, you can see that these ivory pieces, you can see that some of them have got different markings. The red marking, that means that they could be from the same place. So, and then also you can pair them. Pairing means it is just because one elephant carries 2 tusks. Therefore, when you pair the ivory, it means that you can only select 1 tusk to represent that elephant. So you eliminate this sampling processes that you have to do so many samples because it's going to be expensive. And then apart from that, we are able to now take it through in the lab there. Once we receive samples, the samples go through different procedures, which I don't want to go into a lot of details about. But you can receive maybe ivory, or if it's a meat sample, or it could be tools, it could be all this kind of thing. All of them have to go through a DNA extraction process where we get DNA from them. And then after that, we do PCR, and then do sequencing, and then later on generate an expert report that we take to court. But I'll come back to the details. So the things I'm showing in there are some of the tools that I was talking about. And of course, for you to take anything to court, you're required to do proper chain of custody procedures and fill in the necessary documents that will show that what you're doing is actually the correct thing. And after all, generate reports. So for ivory, for example, the process of getting DNA from ivory is very complicated because ivory usually is as hard as an iron, and DNA is usually concentrated in the cementum. If you look at the ivory on a cross section, we have the dentine, and then there's a region called the cementum. It is in the cementum that you can get DNA, and therefore, for that reason, we have to take this thing through a pulverization process where we have to take this ivory into baby powder and then crush it and then get our DNA. That will take some time. As I'm going to show you just a very short, a brief video on that extraction process. Maybe you can watch just for a second. So like what she's doing now, she's trying to clean the first thing is to clean, and she's doing the cleaning, as you can see. So that is actually the process. And you can see that you take the ivory from there, you crush it using liquid nitrogen to make it pulverized into baby powder. So after you have it, now you go through the normal DNA extraction to the sequencing. So that takes a bit of time to do, and it's a very expensive process. So after we do that, we end up doing identifications. You can either do nuclear DNA sequencing or you can do the mitochondrial DNA sequencing. And then from there, you have a complete ID. And you can actually tell if you have once you have a database, then you can tell either locations or you can identify species. If it is bushmeat or any other animal you want to identify, you go through that process. And I think that is the end of my presentation. And I'll be happy to take your questions.
Thank you. Thank you so much, Dr. Moses, for the presentation. So we'll jump right to the Q&A session, and I'll just start by asking a general question. So what is the biggest challenge you're currently working on with regards to the use of DNA evidence in combating wildlife crime?
So DNA evidence, as I've said before, is that most of these of the people who are arrested, the wildlife offenders, they have become so clever that they dispute that when they got with ivory, they will just say this is either cow horn or it is just a horn from any other wildlife. And for that reason, you have to go and test it, get the DNA out of it, and take your report to court. So that is why it's important. Without that evidence, it is difficult to prosecute them.
Okay, thank you. So we had a registration question, and they were asking how financially realistic is this method for small independent research groups, and how widely available is the technology?
Yeah, this is it's very realistic. It depends with what you are looking at. You know, for genetics, there are a number of questions you can ask, and one of them will depend on the sample times you're looking at. If you're looking at just tissues, because you see, apart from this elephant ivory, there are other areas within the elephant that you can get DNA. Yeah, for example, you can get DNA from dung, elephant dung. You can also get DNA from elephant blood or any other easier methods. So to do, will they be genetics questions if they're to do with population or the diseases or all those kind of things. So the method is informed by actually what you're trying to research on. And so the technology is actually, the DNA technology has been with us for many years. And the elephant ivory is fairly expensive, but the other methods are within reach and they're available.
What can I jump? Why is the elephant ivory more expensive?
Yeah, because I've said that getting DNA from elephant ivory is very difficult.
Okay.
Because first of all, you start by, you show the process I was just showing you was for you to understand how it works. You have to cut this thing into small pieces, and then you have to pulverize it first into baby powder before you start online, downstream extraction process. And you see the elephant ivory has got minerals like calcium and other forms of elements that you have to first remove. You have to remove all those things before you start doing the normal DNA extraction. So that one makes it fairly expensive compared to other DNA extraction methods where you will get a tissue or blood or things like that. So it's fairly cheap to do them on the other alternative sources. But if it's the ivory that you have no choice. That is where you have to get the DNA.
Sorry, Netty. I was curious.
Okay, thank you, Dr. Moses. So a follow-up question on that. Where can someone get training on that area of specialization, and how can they start a forensic lab? What do they need to get started with a forensics lab?
Yeah, forensics lab usually it's an expensive thing. Actually, to set up a forensic lab, you need a lot of money to do it because the number of equipment that you will need. If you saw from my screen, I will just show you one of this instrument you see on my screen on my right. That is a genetic sequencer. That is where we use to read our DNA profiles. This piece of equipment is about 500,000 US dollars, just that one piece. And then there are a number of other things that you need. So setting up a genetics lab is an expensive process and it requires a lot of planning. And the training, actually, we have availability of so many universities that are currently training people on DNA work. And for ivory, I would recommend that you can join the university in Seattle, in Washington, that have been working on ivory for very many years, since I think 1990s. University of Washington, Seattle. That is led by Professor Sam Wasa. There's that reading I sent from UNODC. If you look at the author of that document, it was Professor Sam Wasa, who we have been working with for years. And he has perfected these techniques, and he's been taking both PhD students and masters and graduate and all these kind of students. So you can reach out to him or reach me, and I can always do the connections where necessary.
Okay. Thank you so much. Steph, do you want to jump in?
Yeah, of course. I was really curious, Moses, to understand what your experience and opinions were of like a lot of the emerging technologies in this space, because it seems like eDNA and a lot of the technologies are changing a lot and becoming more portable and more accessible. And at least that's what we're hearing from.
Yes.
I am no expert, so I was wondering, have you had any experience or have any opinions about some of the work to develop like barcoding and portable tools or things like work like what Naturmetrics is doing and other organizations too, and the more of the portable tools in this space. What do you think about them?
Yeah, I agree with you. The technology is currently changing rapidly, and tools are getting smaller, and labs are even getting more field-based. So even us, we are actually most of the time using some field-based techniques. But the only challenge that it becomes sometimes quite difficult because wherever there's a court process, admissibility of such evidence from such devices become very difficult because validation of some of these things have not yet been done for forensic caseworks. So for when you're dealing with research, for just research and just show that he did something based on that evidence, it becomes fairly difficult. So we have to stick to our old methods that have been validated and have been reviewed and are fairly accepted in most of our courts around the world.
Do you see this changing anytime soon?
Yes, it's changing. There are a number of methods being validated. For example, we used to use the STR markers for wildlife ID and even human ID. But slowly now, people are going to SNAPes and other new tools which are being validated. Any method that is, as long as it's validated and is peer-reviewed, then it can be used.
Interesting. Cool. Okay. Netty, back to you.
Okay. Thank you. So once you collect the data and you have your evidence, since it's very sensitive, how do you normally handle that in terms of storing the data and also sharing? And which authorities, like in probably Kenya, do you share the information with?
Can you just repeat your question? I didn't get it.
Oh, okay, sorry. So saying like once you have your data collected and you have your evidence, since it's usually sensitive information, how do you handle that in terms of storing the data and also sharing?
Yes, thank you. That's a good question. Data for purposes of court and other forms of data, each and every organization have got data policy. that guide how data is shared. There are data that can be shared and those that cannot be shared, especially data that goes to court is only meant for court. It cannot be shared with anybody else. So we have all those protocols in place, and we have a secure places to keep our data. Whether they're in the cloud or wherever they are, we have password accesses to those data, and we have got validation. We have permissions that we give to those who are authorized to see the data. So that is how we protect our data.
Mm-hmm. Okay, and there was also another question of the information that you, or the evidence that you get. So someone asked if the results are not for ivory elephants. So if you do your testing and you find out that it's not for ivory elephants, what are the rules in terms of if they're foreign species?
Yeah, that is also a very good question. You see, in forensics, you report what you find. It is not, the people who are your customers are the people who are investigating. Most of the time, the people who are investigating these crimes. They're the ones who come to you with requests that we have this amount of ivory or we have this number of meat, and we want you to test and tell us they're coming from what species. So for you to be able to give them accurate results, you need to do the testing following the laid down procedures, and also with the necessary quality controls in terms of will they be samples or whatever they are, and ensure that the analysis you've done is conducted in a guided manner and in a way that is acceptable. And the result that you get, it could be either what they expect, or in some cases, the result might be in the negative, what they are not expecting. So it's all up to them to see what they'll use that result, because they're the ones investigating the matter. If I told you arrested today with somebody got you with red meat, and they say that you have been dealing with suspected maybe ostrich or snakes or things like that, and in the event that this meat is brought to the lab and tested, and they find that it is not ostrich, it is maybe a cow or a goat, the burden of proving that you are the one who was dealing with ostrich is on him. So it's up to him to use the results for whatever he wants. If they're negative, he needs to withdraw the charges or use other forms of evidence that he got you with that are not necessarily the meat.
Okay, thank you. And could you briefly highlight some of the legal or ethical considerations surrounding using DNA evidence as a sampling method for ivory in wildlife crime cases?
Yeah, first of all, for like in Kenya, we have got different, we have got the Wildlife Conservation and Management Act 2013 that spells out penalties that the things that you cannot do with the wildlife. Actually, there is issues of dealing with the dealing with the trophies, wildlife trophies. And a trophy here, I mean anything to do with wildlife, be it the hoof, be it the hair, be it the meat, be it all those things are called trophies. So if you're dealing with them, the law doesn't allow you. In Kenya, it is illegal to either to trade, to hunt, or to do anything with wildlife. So if you're caught with any wildlife, any form of wildlife, you are liable for prosecution. So there are those guidelines that are provided for in that law of the Wildlife Conservation Act of 2013 that that stipulates in different sections of that act the punishments that you need to get when you're dealing with certain species, and especially if you're got with the CITES Appendix 1 species, then the punishment is even very heavy. You'll be taken to jail for 20 years or even life, or pay a fine of up to $200,000 US. So while dealing with wildlife in Kenya is very, very punitive, and that is the reason why the Kenyan government decided to set up the forensics lab to ensure that anybody who is caught dealing with this kind of dealing with any form of wildlife trophy is prosecuted. And apart from that, the ethical issues, of course, in forensic practice, we have got guidelines that on how to deal with samples. We have guidelines that guide our operations in terms of sample handling, sample preservation, and even also how to treat the suspects. Those guys were the criminals who are caught in the police and by our enforcement officers. There are ethical ways of dealing with them. And also because even if you are arrested, you are still innocent until proven guilty. So all those protocols that have been laid down by our national constitution will still be come into play. And the rights of an arrested person they have to be given their rights, and they're processed in the normal way until such time that evidence is given against them, or to either incriminate them or even to exonerate them. Because sometimes they also, you can be arrested and then you're exonerated by the same evidence that was taken to the lab. Because they bring it with the aim of incriminating you, but sometimes the same evidence can also exonerate you.
Okay. Thank you so much. Yuri, did you want to jump in with your question? Okay, I'll just ask on behalf of Yuri. So they're asking, is it possible to date the age of ivory based on the analysis you do?
No, it's not possible to age. Our analysis is only for identification. You can age there are other methods that you can apply, like the isotope method that can be used to age. I can tell you, but by DNA it is not possible to age.
Mm-hmm. And a follow-up to that, how can you use the evidence to link the ivory samples to a specific, say, geographical location, and also trace the individuals who are responsible for poaching?
Yeah, it is most of the time, for you to be able to link any ivory or any pieces of evidence brought to you with a location, you must first have what is called a genetic library. For example, like for Kenya, we must have at least some representatives from those areas that we have elephants. Like in Kenya, we have elephants in the Masai Mara, we have elephants in Savo East, Savo West, we have elephants in Laikipia, and some of them in Mombasa, Marsabit, and all those areas. So we have to have representative samples from all those areas, so that when you are able to, when you get unknown samples, then when you run your assignment testing, you can place them to where they're coming from. And likewise to the continental database. And if you look at the works done by Sam Mwasa and colleagues since the 90s, you'll be able to see that they have been able to collect elephant dung and profile them across Africa. So they have the genotypes of most of the elephants across Africa, and therefore they have that genetic map. And for that reason, it's very easy for them to place any ivory that is arrested to a given geographical location.
Okay, thank you for that. There's one question from the chat. Nicola is asking, are samples stored in stockpiles before court process is complete?
Stockpile? Yeah, any sample that is arrested has to be stored until the prosecution is done with the case before it's either destroyed or returned to the owner.
Mm-hmm. Okay, and I think you've mentioned about having a centralized system, but are people able to monitor whether seizures are linked?
Pardon?
You mentioned about having a centralized system, but are people able to monitor whether seizures are linked?
Yes, we have been able to. The seizures are clearly linked.
Okay. Then another follow-up question. Is that database publicly available?
No, it's not publicly available. As I said, that for the database is held at the University of Washington, and the reason why it's not publicly available is because of what it's being used for.
Okay, I guess because it's sensitive information, then it would be to specific people and authorities.
Yes.
Yes, okay. Another question, what are some of the challenges that are associated with using DNA evidence? Probably just highlight a few, such as like sample degradation or contamination.
Yes, one of the challenges you brought it right is one of them is samples preservation and how it's managed from the field. That's one of the challenges. The other challenge is usually the documentation, that what we're calling chain of custody. When somebody is arrested with either an exhibit, be it ivory, be it meat or whatever it is, there are various documents that have to be filled in order to ensure that this person gets to court and is prosecuted. Sometimes this, because there are so many people who are involved, most of the time you find that a case is thrown out because there was no proper chain of custody documents to help with securing this evidence. And that is a big challenge. The other challenge I've told you is regarding the costs of analysis. They're fairly high, and that makes it very difficult for you to conclude all cases, because some of them, you might drop them because you're not able to analyze. Then apart from that, also we have issues to do with expertise. You know, this is a lot of, you require people who are, you need experts in this field. And therefore, challenges with gaps in terms of expertise in different areas also comes into play. And apart from that, we also have issues to do with let me say, communication. This break sometimes you lose critical evidence. So those are some of the challenges that we see from time to time.
Mm-hmm. Okay. Thank you so much for that. And in terms of the data, would you be able to approximate, like with time, the level of precision and confidence that is required when you are putting up evidence for that?
Yes, everything, if it's comparisons, it has to be 100%, because if you, any moment there's introduction of doubt, it means that the evidence is not, the threshold of that is required to prosecute is not met. And the moment you say it was 80% similar to something, that means that it's not really similar. So you have to make it, it has to be, you have to ensure that anything must meet the thresholds that are required for you to sustain it before court. And we have guidelines to tell what are the thresholds you need for this kind of evidence.
Mm-hmm. Okay. And in your experience, have you been able to use other methods in combination with the DNA evidence in your work?
Yes, we do morphology. That is just trying to look at the features. Like in ivory, you know, ivory is unique because they have got some Schreger lines. Those lines that the angles that are measured to give you characteristics of the ivory, and you say that because you can see the Schreger lines and they meet the percentages required, therefore it's ivory. So those are also sometimes accepted. But you know, with morphology, sometimes it becomes very subjective. It depends with who is looking at it. So DNA actually is one of the most recommended methods for forensic identification.
Mm-hmm. Okay, thank you. And what's the next immediate step after doing the sampling before now going to court to show your evidence?
Yeah, after sampling, the immediate step, I remember from my chart, I explained that after you get your sample, you have to go and extract DNA from it and then do all the pipeline, the issues with lab analysis. So that one must be done within the lab. So, and that will take you time. So there are different stages within the lab that you have to go through, which I really don't want to go into the scientific details because I'll confuse many of my listeners.
Mm-hmm. Okay. Thank you so much. I think we'll wrap it up with our final question. And that would be, what is the next big development in ivory sampling to generate intelligence data?
One of the biggest developments is that the movement of STR, we used to call them short tandem repeats. We are now moving from the use of those markers and moving into the newer ones. We're also trying to deploy new and more, the small tools, as the other lady was asking. We're trying to develop the robust tools to analyze this kind of data. There are so many other things that have been developed in the recent past that have been helping analysis, looking at the old methods that we used to use. So analytical pipeline has become more simpler, making this work reproducible across labs. And this is something that we think is going to make work much more easier. And again, also for extraction of DNA from ivory, there are newer methods that are being developed now other than the one that I just showed you.
Okay, thank you so much. I'm not sure if anyone else has any questions. Okay, I guess not. So thank you so much for joining us for today's session, and thank you for the great presentation, Dr. Moses, and the Q&A session. We will have the recording up next week, and so you'll be able to access it on WILDLABS and our YouTube channel. Our next tutorial will be on the 13th of April at 4 p.m. EAT and 2 p.m. GMT, where Alina Peter, the founder of Contech Africa, will take us through a tutorial on how to extract spatial data from EarthRanger to create maps on QGIS and ArcGIS Pro. Before that, we'll have a variety hour session next week on the 29th of March. And you can register to attend using the link that Steph will share in the chat. Thank you once again, and have a lovely rest of your day and week. You can still hang around after the session and ask any questions you have. Thank you so much.